Hello everyone, welcome back. So now let's try an example of figuring out velocity and acceleration from a curvilinear path. So what we have right here is we have a path that is described by 0.05 x squared. A box is sliding down this path. Now we know that at x equals 5 meters, our velocity is this in the x direction. Now, acceleration is this. We want to find out what the y components of velocity and acceleration are. So, here's your plan. What I'm going to do now is I want you to pause the video. And then after you paused, try this out. And if you can't do it, come back, watch the rest of the video, and we'll do it together. So, 3, 2, 1. Okay. You've now managed to do this entire thing in 3 seconds, no less. And so, let's continue and see how you did it. So first off, we got to figure out the y component of velocity is by taking a time derivative. Remember, even we don't see a time in here, we know that x is really x of t, and so we can take a time derivative of it. And so we'll get that y dot equals 2 times 0.05 x dot, where x dot is dx dt. Now, where does this come from? Well, it's the chain rule. So I have d dt of 0.05 x squared. And so I had to do the chain rule for the x squared. And so what I do is I say, okay, well, 0.05, you're constant, I'm going to bring you out. And I do first d last, so x times x dot, plus last d first. Okay, so x dot x. Obviously, these are the same thing. So I have 2 times 0.05 x dot, where x dot is simply dx dt. Okay, let's clear off some space. Whoop. Turned way ahead, I hit the wrong button. I can do the same thing to get my y double dot, where I take time derivative of this. So why don't we do it again? So first d last plus last d first. So 0.1 times first d last x double dot plus last d first x dot. Okay, and then I have this right here. So this is where everything came from. This is how we got these functions. And now we can put in what we know, which we know the acceleration at 5 meters, we know the position at 5 meters, and we know the velocity, at least in the x components, at 5 meters. And so we plug that in, because we know this. What we get is that the y velocity at 5 meters is negative 1.5 meters per second, and that the y acceleration at that time is 0.15 meters per second squared. So the velocity is going down, but the acceleration is slowing it down. So eventually it might either reverse and go up again, or it'll go to 0. Now I hope this helped you, and if you want, we'll do another problem next time. So have a good day, and I'll see you all soon. Bye-bye.